Hey, we have here on the board another integral. We've got the integral of 1 over x cubed plus x squared plus x plus 1 dx. Okay, let's get right into it. And I think we can definitely do some factoring on this denominator to get started. So like with these two terms, I can factor an x squared out here, and this is going to become x plus 1, which is nice because we also have an x plus 1 right here. So then now we have this x plus 1 in common, so now I'll factor that out. So when I rewrite it, we're going to have this as x plus 1 times x squared plus 1. Just noticing we have a 1 coefficient there. But then from here, we're in a good position for partial fractions. So what I'm going to do is let's just break this up. What I can do is split this into two integrals. One's going to have x plus 1 in the denominator, and this other one will have x plus 1 in the denominator. That's a weird looking integral sign right there, but let's just keep going and deal with it. Now for this integral, because the degree of this polynomial is just first degree, we're just going to have a constant term here. So I'm going to write this as c. But now on this one, we've got a second degree polynomial, so we're going to want a first degree polynomial in the numerator. So I'm going to write this as ax plus b. And now with the one in the numerator here, what I can do is we can just write this as a fraction and we can solve for our variables. So what I want to do is I'm actually just going to use the cover up method just to find our c value. And so what I want to do here is we want to plug in a minus 1. Actually, if we have a minus 1 here, that's going to make this expression 0. We cover that up. We plug our minus 1 in here. Minus 1 squared is going to be 1 plus 1. 1 over 2 is going to give me 1/2 for my c value. And then we can't do quite the same thing with x squared plus 1, but we can still choose some other values. We used minus 1 already, so we can't use it because we used minus 1 here. But we can use any other value basically. So what I'm going to do is choose x to be 0. And we'll just plug that in everywhere we see an x. So doing that here, we're going to have 1 times 1 in the numerator here. So our left side's all going to become 1 over 1, or just 1. Then plugging a 0 in here, 8 times 0 is 0. We'll have b. If we plug a 0 in here, we're going to have 0 plus 1, so that's just going to be a 1. So we're just going to have b here. We already know our c is 1/2. And then we plug a 0 in here, 0 plus 1 is just 1. So we're just going to have a half there. And then if we just solve for this b value, we're going to find b has to be 1/2. Okay, now we just need this a value. We've already used 0, we've already used -1, so let's use 1 because that's going to be another easy value. So we'll say x equals 1. So we'll plug in that 1 there. We're going to have 1 over 1 plus 1, we're going to have a 2. Then here we're going to have 1 squared plus 1, we're going to have another 2. So on the left side, we're actually going to end up with just 1 over 4. And then let's plug in the 1 to everything else. So we're going to have 8 times 1, so we're going to have a plus our 1/2 value, then plugging 1 in here, then plugging 1 to the denominator, 1 plus 1, we're going to have a 2 there. Then we have our c, which is 1/2, plus here again, 1 plus 1, 2. And I think I'll just multiply through by 4 to kind of clean it up. So this is going to give me a 1 on the left side. Then multiplying in this 4, that's going to give me 2a plus 1. And then here it's going to give me another plus 1. So this is going to end up being 2a plus 2. And so if we just solve for a, we're going to find that a is going to be minus 1 over 2. And now at this point that we have our a, b, and c value, I'm just going to plug this back into our integral and we continue. Okay, now from here I can just take this integral and we can break it in half into two integrals right there. So on this first one, what I'm going to do is I'm going to take a minus 1/2 out front, and we're going to have x over x squared plus 1 dx. And then here I'm going to take this half and I'm going to bring it out front of the integral so that we have just 1/2 times dx over x squared plus 1. And then for our third integral, I think we can just integrate this one rather than bringing it along. So this is actually just going to be 1/2 times natural log absolute value x plus 1. Now here, if I just take this x and multiply it by 2, and then if I divide by 2 out front, so I'm not changing it. Well, for this, I think we can just do a u substitution in our head, because if I make this my u right here, x squared plus 1, well then our du is going to be 2x dx, and that's what we have here in the numerator, so du. So if I multiply minus 1/2 times half, we're going to have minus 1/4 in front here. This is going to be natural log of u, but u is just x squared plus 1, and because x squared plus 1 is always positive, I can drop my absolute value there. Then we're going to have this 1/2 right here. The integral of dx over x squared plus 1, this is just arctan of x, so we can write that. And then I can just copy this piece down that we just did, half ln x plus 1, and then add a plus c, and that's it. Okay, not too bad. So just a little factoring and then partial fractions. So we'll stop it there. Thanks everyone for watching. Have a great day.